Hey everyone, welcome to exercise 17 where we take a look at polynomials. Now, you've already been doing polynomials this whole time with the quadratics where we have x with a power of 2 and x to the power of 1 in a ax squared plus bx plus c generic equation. Polynomials just builds off quadratics. Okay, we start introducing cubics. And so 17.2, we just have a basic introduction to the polynomial terms you might run into. For example, what is a polynomial in X? Sometimes, well, most of the times, pretty much always, we denote polynomials as PX as an abbreviation. What it means is the expression that follows will only contain a non-negative integer power of x. In other words, whenever we have an x in the expression, the power is always going to be positive and it's always going to be an integer. In other words, any number greater than 1 that is an integer, inclusive of 1 as well. So the degree of a polynomial in x is the highest power of x in the expression. For example, if we have 3x plus 1, this polynomial has a degree of 1, okay, because x here is to the power of 1. In other words, we can call this a linear polynomial, or in other words, a linear relation. Notice how we've been doing this basically since the start of the year. If we have a x squared plus 4x take away 7, this is a quadratic equation now, or a quadratic expression for that matter, because there's no equal sign. What we say here is a polynomial has a degree of 2 because the x has a power of 2, and that's the highest degree. In other words, we can call this a quadratic polynomial. In the equation, negative 5x cubed plus x on 2. This is a polynomial of a degree of 3. In other words, a cubic polynomial. And this one we haven't seen so much of just yet. Lastly, if we have a 10 by itself, the polynomial has a degree of 0, okay, because, well, if we think back to index laws, anything to the power of 0 is 1. So imagine this as 10x to the power of 0, which means it's 10 times 1, which is 10 by itself. Now, any expressions which contain a term similar to any of these are not polynomial. So we cannot have fractional polynomials where we've got 1 on x. We cannot have negative integers. We cannot have surds. We cannot have x as a power. We cannot have sine x, and so on and so forth. Okay, can I make it explicitly clear? For it to be a polynomial, the power needs to be a positive integer. So, for example, the following are not polynomials, okay? If we have a 2 on x in any of the 3 expressions, not a polynomial. If we have a root x anywhere along in any of the terms in the expression, not a polynomial. If we have a sine x or any other trigonometric ratio, that is also not a polynomial. Lastly, we've just got some key terms, which I'm sure you've seen before, but again, this is an intro lesson, so that's why we're going to recap everything we've learned up to this point and introduce some new vocabulary. So in the expression 6x cubed plus 13x squared take away x plus 1, well, we've got x as our variable or pronumeral. 6 is a coefficient to x cubed, 13 is a coefficient to x squared, negative 1 is a coefficient of x, and then we've got positive 1 as our constant, okay, because it doesn't change. All of these, because they're separated by plus and minus signs, again, they are all terms in their own. So we've got 4 terms in this cubic equation, or cubic expression, sorry, or cubic polynomial. The leading term is 6x cubed because it has the highest power. And we always want to organize our expression to have the highest power first, or to the far left. Okay, and then the constant to the far right. And then everything else in between, in the middle, based on the x power. the leading coefficient is 6 because the leading term is 6x cubed, and any polynomial with a leading coefficient of 1 is called a monic, just like the quadratic equations where we dealt with monic and non-monic factorization. All right. Anytime we've got an expression where the cubic or the coefficient in front of the x cubed is not 1, that's non-monic. So 6x cubed plus 13x squared, take away x plus 1. That here is a non-monic expression. Lastly, an example where polynomial is useful. So here, the surface area of this plant hothouse of length L and height X can be approximated by the polynomial Sx, okay, surface area, that's why it's S, equals pi times x squared plus length times pi times x, take away 4, which will tell us the surface area of this plant house. Okay, that's it for exercise 17.2. It just goes through a lot of the key vocabulary. Make sure you don't skip out on this exercise because it sets us up for every other exercise from here on in. Thanks, everyone.